Hey everyone! Welcome back to ZoomInData. And this is episode 16 of our KQL Concepts Deep Dive series. Today we are doing a deep dive into null semantics, three-valued logic, how coalesce works, and the crucial difference between is null and is empty. We are keeping everything pure concepts and interview focused. If you missed episode 15 on calculated columns and side effect-free design, it's a great one to catch up on. Let's get started. Here is our roadmap for today. KQL uses three-valued logic for null comparisons: true, false, or unknown. Null propagates in most expressions and aggregations. Coalesce returns the first non-null value in a list. Is null checks for null. Is empty checks for empty string or null. Null handling affects filtering, grouping, and join behavior. Understanding null semantics prevents subtle bugs in real queries. Let's dive into the details. Let's start with three-valued logic. This is the heart of null behavior in KQL. Comparisons involving null return unknown, not true or false. Unknown propagates. True and unknown equals unknown. False or unknown equals unknown. Where clauses treat unknown as false, so rows with nulls are filtered out. Aggregations like sum and count ignore nulls. Count includes them. Three-valued logic. Null propagation is everywhere in KQL. Most operators propagate null. Null plus 5 equals null. Null equals null equals unknown. That's where coalesce comes in. Coalesce, expr1, expr2. Returns the first non-null argument. It's useful for default values and safe chaining. Coalesce short circuits, stops at the first non-null value. Null propagation combined with coalesce gives you predictable, safe handling of missing data without surprises. Check out this side-by-side diagram. It makes null propagation and coalesce super clear. On the left is the propagation chain. Start with null. Add 5 and you still get null, then compare null to 10 and you end up with unknown. Null spreads through expressions and comparisons like wildfire. Everything it touches becomes uncertain. That's three-valued logic doing its thing. On the right is the coalesce chain. Start with null, try 5, boom, it stops right there and returns 5. If 5 was also null, it would continue to the next value like default. Coalesce short circuits at the first non-null, no spreading mess. The middle arrow with the shield icon says safe defaulting. That's the power. Propagation keeps nulls dangerous and unpredictable, but coalesce wraps them safely, giving you a clean fallback value without letting uncertainty take over. Use coalesce whenever you want reliable results, even when data is missing. Now the crucial difference between is null and is empty. Is null, column, returns true only if the value is null. Is empty, column, returns true if the value is null or an empty string. Is empty is string specific. Is null works on any type. Use is null for general null checks. Is empty for string emptiness. Common pitfall. Is empty, null, returns true, but is null, returns false. Mixing these up is one of the most frequent subtle bugs in KQL queries. Null behavior changes how filters, joins, and grouping work. In where column equals value, nulls are excluded because unknown is not true. Same for equals, nulls are still excluded. Joins treat null keys as non-matching. Null does not equal null. Group by null creates a single null group. Nulls are ignored in most numeric aggregations but are counted in count. These rules are consistent but surprising if you're coming from two-valued logic databases. They show exactly how nulls behave in the most common operations in KQL. First box on the left, filter, where column equals something or not equals something. Nulls get excluded every time. The unknown result from any null comparison is treated as false, so rows with null just vanish from the output. See the crossed out icon? Excluded. Middle box, join. When joining on a key, Null never matches null. Null key means no match, period. So nulls on either side stay unmatched. Icon here is the broken link, no match. Right box, group by a column that has nulls. All the nulls collapse into exactly one group. Not scattered, not ignored. One single null group. See the single group icon. One group. These three rules trip people up constantly, but once you internalize them, filter excludes nulls, join ignores null keys, group by collects nulls together, your queries become way more predictable and bug-free. Why does this topic matter in interviews? Interviewers test null handling knowledge frequently. Common questions include, why does null equals null return unknown? And, is null versus is empty? Understanding three-valued logic shows deep language mastery. This topic appears in debugging, correctness, and optimization roles. Explaining coalesce and propagation demonstrates practical expertise. Get this right, and you avoid a lot of real-world bugs, and impress interviewers. To wrap up, KQL uses three-valued logic: true, false, unknown for nulls. Null propagates in expressions and comparisons. Coalesce safely returns the first non-null value. Is null checks null only. Is empty checks null or empty string. Nulls are excluded in filters and joins but grouped together. Master these rules, and your queries become more correct, safer, and easier to debug. That's episode 16 done. Thanks for spending time with me on ZoomInData. Next in episode 17, Grouping Mechanics, we will explore the by clause, cardinality explosion risks, and how grouping really works under the hood. Homework to lock this in: explain to someone or out loud, why does null equals null return unknown in KQL? Think of a query where coalesce prevents null propagation bugs. Answer this interview classic: what is the difference between is null and is empty? If this helped, like the video, share it with anyone prepping for Azure interviews, subscribe for episode 17, and drop a comment with your biggest takeaway today. Thank you so much for watching ZoomInData. See you next time. Keep zooming in on those concepts. Bye for now.